Children, now let us start the new chapter, Gravitation. You know that all objects fall down when released from height. All objects fall down when released from height. Moon goes around Earth. All the planets go around the Sun. The moon goes around the Earth. An object, when thrown upwards, reaches a certain height and then falls downwards. In all these cases, there must be some force acting on the objects, because in the previous chapters you have learnt about the motion of objects and force as the cause of motion. If there is any change in the position of the object, if there is change in the speed of the object, there must be some force acting on the object to change its position of rest or position of motion. So in all these situations, there must be some force acting on the object. And Sir Isaac Newton could grasp that the same force is responsible for all these, that is, the gravitational force. In this chapter, we shall learn about gravitation and the universal law of gravitation. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both the cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line, so it must be attracted by the earth. But we do not really see the moon falling towards the earth. The moon falls towards the earth at each point of its orbit instead of going off in a straight line. So it must be attracted by the earth. But we do not really see the moon falling towards the earth. Now let us take one activity here. Let us understand the motion of the moon around the earth by doing one activity. Take a piece of thread. Take a piece of thread. Tie a small stone at one end. Tie a small stone at one end. Hold the other end of the thread. Hold the other end of the thread and whirl it round. Whirl it round as shown in the figure. Note the motion of the stone. Here you know that here it is whirled by hand and the stone moves in the circular path. And release the thread. Again note the direction of motion of the stone. Here you know that if the stone is released here, it moves in this direction. If the stone is released here, it moves in this direction. Similarly, if the stone is released here, it moves in this direction. So here before the thread is released, the stone moves in a circular path. Here before the release of the thread, the stone moves in the circular path with a certain speed, and the direction of the motion changes at every point. At every point, the direction of the motion changes. The change in direction involves, you know that there is change in velocity. Here, as the direction of the motion of the stone changes, you can say that is nothing but change in velocity. Change in velocity is nothing but acceleration. So here, each and every moment the direction of the stone changes, and that is the acceleration motion here. So there must be some force acting on the stone to accelerate it, to accelerate the stone, there must be some force acting on it. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. Here, this force is acting towards the center, and this force is responsible for the acceleration and keeps the body moving along the circular path. This force is called the centripetal force. Here, the force which is responsible for the motion of the stone and also for the acceleration. In the absence of this force, the stone moves in the straight line. In the absence of the force, the stone flies off along a straight line. This straight line will be tangent to the circular path. So if you consider the circle and this is the tangent. So what is tangent? It is a line that meets the circle at one and only one point. The point is called the point of contact, and the line which meets the circle at only one point is called the tangent to the circle. So you consider if it is a circle with center O and P is a point at which the line segment meets the circle, so that line is AB. So APB is a tangent, and if the force is not there, the stone flies away in this direction, and that line will be the straight line, and the straight line will be the tangent to the circle. Here, this is the tangent to the circle. If it is released at this point, then it flies on this direction, that is also tangent to the circle. If it is released here, it flies in this direction, it moves in this direction, that is also tangent. So you take tangentially, it leaves the circular path. The motion of the moon around the earth is due to centripetal force. Same thing you can observe in the case of motion of the moon around the earth. In this situation, the force is exerted by U, that is towards the center. If you consider this is the center of the circular path, the force is directed towards the center, and the force is exerted by U, and this is directed towards the center, which is called the centripetal force. Centripetal force. Centripetal force. So this force is responsible for the motion of the object along a circular path. And if you consider this is the moon and this is the earth, and there must be some force which is directed towards the earth, which acts as a centripetal force, that is nothing but gravitational force. Earth's gravitational force acts as a centripetal force. Here, in this activity, the force is exerted by U, which is directed towards the center. That is the centripetal force, which is responsible for the motion of the stone along a circular path. And in the situation, the motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth, which is called the gravitational attraction, gravitational force. If there were no such force, the moon would pursue a uniform straight line motion. So, the force is exerted by the earth, that is directed towards the earth, and that force is responsible for the circular motion of the moon around the earth. So, for each and every circular motion of the object, there must be centripetal force which is directed towards the center. All the planets are moving around the sun, and the centripetal force in that motion is the gravitational force exerted by the sun. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards an apple. Why is it? According to the third law of motion, the apple does attract the earth. If there is a attraction by the earth, then also there is a attraction by the apple. But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. So, the mass of an apple is negligibly small if it is compared with the mass of the earth. So, you do not see the earth moving towards the apple. Same argument for why the earth does not move around the moon, because you know that if you compare the mass of the moon with the mass of the earth is having more mass than the moon. So the moon is moving around the earth, but earth cannot move around the moon as it is having more mass than the moon. In our solar system, all the planets go around the sun. The argument is also same here, because you know that sun is having more mass than all the planets. All the planets are having less mass than the moon. If you compare with the mass of the planets with the mass of the sun, it is negligibly small. So all the planets are moving around the sun. Now you can conclude that there is a attraction between the moon and the earth. Moon attracts earth and also earth attracts moon. There is an attraction between the apple and earth. There is a force of attraction between the apple and the earth, and if you compare the sun and the planets, there is a attraction between the sun and the all the planets. The force with which earth pulls everything towards itself is called gravitational force or gravity. Similarly, moon is also having gravitational force. Earth is having gravitational force and it attracts the moon towards it. Moon is also having gravitational force, it attracts earth towards it. But the gravitational force of earth is more than the gravitational force of the moon. So the moon is moving around the earth in the circular orbit. All the objects in the universe attract each other. Every object in the universe attracts every other objects with a force. That force is called the gravitational force. The force of attraction between objects is called the gravitational force. Now you write the definition of the gravitational force. What is the definition? All objects in the universe attract each other. All objects in the universe attract each other. This force of attraction between objects is called the gravitational force, called the gravitational force. So what is gravitational force? All objects in the universe attract each other. This force of attraction between objects is called the gravitational force. Now we write the example here. Attraction between between Earth and Moon. Earth and Moon. And also you can write attraction between Sun and planets. Sun and planets. Then you take attraction between man and earth. Attraction between man and earth. These are some examples of gravitational force. Children, now let us write about the centripetal force. What is centripetal force? To move the object along a circular path, there must be force to cause the acceleration and to keep the body along the circular path. This force is directed towards the center of the circular path and it is called centripetal force. Here, if you consider, this is the O is the center of the circular path and it is the object along the circular path. This is the object moving along the circular path. You know that its direction changes continuously, so it is an accelerated motion. To cause the acceleration, there must be some force. And by changing the direction of the object continuously, the object is made to move along the circular path, that is by the force centripetal force. So this force is directed towards the center of the circular path and this is called centripetal force. So what is centripetal force? So you write that what is centripetal force? To move the object along a circular path, there must be force to cause the acceleration and to keep the body along the circular path. This force is directed towards the center of the circular path and it is called centripetal force. Now you write the tangent to a circle. Tangent to a circle. Tangent to a circle. What is tangent? A straight line that meets the circle at one and only one point is called tangent to the circle. So you write that a straight line that meets the circle at one and only one point. At one and only one point is called tangent to the circle. Is called tangent to the circle. So you can draw. Now you draw the circle. You draw one circle and draw the tangent AC which touches the circle at only one point B. So here you can say that ABC is a tangent to the circle at point B. In the figure, ABC is a tangent to the circle at B. You learnt about the radius, chord, diameter, etc. Radius is the line joining the center and a point on the circle, and chord is the lines joining the 2 points on the circle, and diameter which passes through the center of the circle, that is also chord of the circle, that is the biggest chord. But here, so tangent is a line which meets the circle at only one point. You can draw any number of tangents to the circle, and in this circular motion, you know that if the stone is released, if this thread is released, what happens? The stone moves tangentially. If it is here, it moves this way, that is tangentially. It moves along a straight line. The straight line is tangent to the circular path. So the word tangent is taken here.